In this video, I'm going to show you how to convert a vector component vector like this one, right? And that should have a little hat over it, right? 5.1 meters in the x-hat and negative 1.70 meters in the y-hat. How to draw that vector, how to convert it to an angle magnitude vector. That's what I mean by AM. So vector component converting to angle magnitude vector, okay? The first thing, and this is the hardest step, is to draw the vector, okay? So we're going to draw this vector. And what you do is you just draw the x. I always draw the x component first, right? So draw that guy over, okay? And then this is, of course, down from there, right? So this is our 5.10. And then we're going to go down 1.7. And I'm not measuring that, but the 1.7 is smaller than the 5.1, so I'm going to draw it definitely smaller. Okay? And then the vector is this guy here. Hard for me to draw as straight a line at the angle, but that's the vector right there. Okay. Now the next thing I'm going to do is we got to find an angle and a magnitude. So let's find the angle first. Okay. So this side is the opposite side. This side is the adjacent side to this angle here. And I like to find that angle. You could find this angle if you want. It's up to you. Okay. But I always find the angle between something and the vector. That's the best angle to find. I'll show you that, right? So remember that the tangent of that angle is the opposite, right, over the adjacent. This is from SOHCAHTOA. So therefore, that angle is the inverse tan of the opposite over the adjacent. Okay? So I'm going to use the inverse tan function. So you go second tan, right, of 1.7 divided by 5.10. Now, I'm not putting the minus sign in there because I don't need to, okay? So I'm going to go second tan of 1.7 divided by 5.1, and then right parenthesis, and I get 18.435 degrees. And I'm not done with that yet. I want to make a trig angle out of that, right? Okay, so let me show you how to do that. By the way, if you get this angle there and you label that angle as 18.435 degrees, you're done. I mean, we're fine, you know, with that angle, right? But let's find the trig angle too, just for fun, because then we'll be like the uber geeks here, right? The trig angle goes like this. So it's actually 18.435 degrees short of 360, which would be all the way around, right? So the trig angle, which is what's on the worksheet, right, is 360 minus 18.435, right? So if I subtract that, I get 341.56. So about 342 degrees would be my trig angle. Okay, and then the last thing is we want to find the magnitude. Magnitude is just a big word for how big the vector is. That's the length of the hypotenuse, right? So that's simply going to be the square root of the opposite side squared plus the adjacent side squared, right? So that's going to be the square root of 5.1 squared plus 1.7 squared. Now, don't put the minus sign in there because, in my opinion, your TI calculators have a wonky order of operations. If you say plus a negative 1.7 squared, it interprets that as the opposite of 1.7 squared, not negative 1.7, the quantity squared. So leave your minus signs out of here, leave the minus signs out of here. So I'm doing that. Square root of 5.1 squared plus 1.7 squared. And I'm getting 5.3758. And this is meters, right? Because these guys are in meters. Right? And so with sig figs, we'd have to say 5.38 meters at 342 degrees. Or we could just simply, by the way, draw this vector here and just say that angle there is 18.4 degrees. And let someone else figure out the trig angle, right? This guy's 5.38 meters. That would be just fine as well, okay? I don't care if you do the trig angle, but the trig angle is what's going to be on the examples and on your worksheet, okay? So that's how to do that. Okay, and then I'll do a bunch of examples here.